Hello everyone, today we'll be continuing our review of pre-algebra for college algebra, and today we'll be practicing some exponents. In the last video we went more in depth on the rules of exponents and went through a few simple examples, and today we're going to go through a few simple examples again, but then about 4 more complex examples where we're going to also simplify expressions. So if we first start off with the formulas from last time as a quick refresher, we have AB times AC equals AB plus C. A to the B to the C equals AB times C. A to the negative B equals 1 over A to the B. A to the B over A to the C equals A to the B minus C. A to the 0 equals 1. And then finally A over B to the C equals A to the C over B to the C. Alright, let's get into the first example for the day. And this one is going to be a simple one. So we have 7 to the 0 times 7 to the negative 8 times 7 to the 0 over 7 to the 0. Here, the main formula we will use will be 7 to the 0 equals 1, since A to the 0 equals 1. So if we replace every instance of 7 to the 0 with a 1, we have 1 times 7 to the negative 8 times 1 over 1. And since anything multiplied by 1 is itself, anything divided by 1 is itself, we'll have 7 to the negative 8th left. To finally simplify this, we'll use A to the negative B equals 1 over A to the B, and end with 1 over 7 to the 8th as the final answer. If we move on to the next example, we have 2 a to the 12th times 2a cubed. Again, pause the video if you would like to work out by yourself. Alright, so first we will do 2 times 2, then a to the 12th times a cubed. 2 times 2 equals 4. A to the 12th times a to the cubed equals a to the 12th plus 3 equals a to the 15th. Putting these together, we get 4a to the 15th. Alright, now, next we will move on to our last, more simple example. Here, we will do 10x cubed squared. Take a minute to walk through this problem yourself. Alright, again, we will walk through the product rule by moving the squared to the 10 and to the 3. We will have 10 squared, x to the 3 times 2. This gives us 100, x to the 6th as the simplified form. Alright, that was our little warm-up, and now we're going to get into some more complex examples. I have about 4 for us to work out. So, we have x squared over b to the 5th times c to the negative 2nd over x to the 7th times c to the 7th cubed over b to the negative 20th times x to the 0, b to the 0, c to the 0, x to the 27, 0. Alright, take a moment to pause this video and then walk through this problem yourself. Alright, so to walk through this problem, what we're going to do is we're going to go through each fraction and simplify it down as much as we can. X squared times b to the 5th is already simplified, so we'll move it downhill. The second fraction, c negative 2 over x to the 7th, can be simplified more if we use a negative b equals 1 over a to the b. We have c equals c to the negative 2nd power, so by this formula we can move it to the denominator and then take away the negative sign, simplifying down to 1 over c squared x to the 7th. Since this is fully simplified, we can move it down to the bottom. Alright, here we have c to the 7th to the 3rd. If we use the product rule, we can do c to the 7th times 3 equals c to the 21st And then again, if we use the negative exponent rule, we can make it a positive exponent by switching the place in the fraction. So since it's in the denominator, we'll move b to the negative 20th to the numerator and make it b to the 20th. So this will simplify to b to the 20th over c to the 21st over 1. And as this is fully simplified, we can move it to the bottom. Finally, we have x to the 0, b to the 0, c to the 0, over x over 27 to the 0. Well, since anything to the 0 power is 1, we have 1 over x to the 27th times 0 by the product rule, giving us 1 over x to the 0. And since x to the 0 is a variable raised to the 0 power, it is also 1, giving us the simplified as 1 here. Now, luckily for us here, this is multiplication, and since this is not addition or subtraction, but in fact multiplication, we do not have to have a like the denominator. We can just multiply the numerator and then multiply the denominator together and then combine them. So if we start with the numerator, we have x squared times 1 times b to the 20th times c to the 21st times 1, giving us x squared b to the 20th c to the 21. In the denominator, we have b to the 5th times c squared times x to the 7th times 1, giving us b to the 5th c squared x to the 7th. Combining them together, we have x squared b 20th c to the 21 over x to the 7 b to the 5 c to the squared. Now, I lined it up like this so you could clearly see we have x, b, and c, and we can use the division rule of exponents in order to simplify them. So if we start with x, we have x2 over x7, so we have x2 minus 7 equals x to the negative 5th. When we go to b, we have b20 over b5, so we have b20 minus 5 equals b to the 15th. And then lastly, we have c21 over c2 equals c21 minus 2 equals c19. Lastly, we can use the negative exponent rule to move the x to the negative 5 to the denominator and making it x to the 5th. So by doing this, we will have b to the 15th over c to the 19th over x to the 5th as our simplified form. Alright, we're going to move to the next practice problem now, which is 10x squared plus c squared b to the 5th over x plus b to the 0 x squared over c. Now what I want us to do is I want us to take this problem and expand it into one fraction. So I will give you a second to pause the video, write the problem down, and solve it for yourself. Alright, so if we get into this, if we start with the first term, we can use the product rule. We can move the 2 to the 10, and the 2 to the x squared, giving us 10 squared x2 times 2, or 100 x to the 4th. On the second term, we cannot simplify it anymore, so we have plus c squared b to the 5th over x. And then finally, on the third term, we can simplify b to the 0 equals 1, since anything to the 0 power is 1. This gives a simplified form of x squared over c. Now, unlike the last problem, here we have addition and subtraction. So that means if we want to if we want to add the fractions together, they had to have the same denominator. So we have on the first term a denominator of 1, the second term x, and the third term c. So due to that, our common denominator will be xc. So if we make 100x to the 4th over x over c, we will have to do xc for xc times 100 x over 4 over 1, giving us 100 x over 5c xc. Here, for the second term, we will have to do c over c times c squared b to the 5th over x, giving us c cubed b to the fifth over cx. Finally, we must do x over x times x squared c, giving us x cubed plus xc. Okay, next, since we have a like denominator of xc for all three fractions, we can add them together. So if we do for the numerator, 100 x to the fifth c plus c cubed b to the fifth plus x cubed. Now, all we have to do is combine like terms. Luckily for us in this problem, there are no like terms in the numerator, so this is the simplified numerator. And the denominator is just what the common denominator is of xc. If we combine these together, we have 100 x to the fifth c plus c cubed b to the fifth plus x cubed over xc. And again, this is the answer to the problem. This is the expanded form. Alright, for the next problem, we're going to do the opposite of what we just did. Instead of expanding into one fraction, we're going to break down the fraction. So here, we have 11x squared plus 17b squared minus c to the fifth plus d cubed over x, b, c, d. And I want us to break this down to where it's not in one fraction. So go ahead and take a minute to write this down and try it yourself. Alright, now, if we get into the problem, what we can do is we can break this down by taking all the spots where we are adding or subtracting, and then taking the term to the left of that, and making that its own individual fraction over the denominator. So we take this, we have 11x squared over x, b, c, d, plus 17b squared over x, b, c, d, minus c to the fifth over x, b, c, d, plus d cubed over x, b, c, d. If you remember from the last example, when we add fractions or subtract fractions, we must have a common denominator. Here, we have common denominators, so if we add numerators, we will be back to this expression at the top. So really, thanks to us being able to do this, we're allowed to break down the fractions. So if we move at one problem at a time, we can deal with x squared over x as x2 minus 1 equals x, giving us 11x over b, c, d. We can deal with the b squared over b as b2 minus 1 equals b, giving us 17b over x, c, d. We can deal with the c to the fifth over c as c to the fifth minus 1 equals c to the fourth. So c to the fourth over x, b, d. Then finally, we can deal with d cubed over d as d cubed minus 1 equals d squared, as simplifying it as d squared over x, b, c. And again, this is the simplified form to the problem. Alright, now we will wrap up this video with one more problem, and that will be all for the day. So the last problem will be x over 4 cubed times 5x squared times 7 y to the negative 7. So again, go ahead and write down this problem and attempt to work it out yourself. Alright, again, we will work one term at a time, attempting to simplify it. So here, we will use the quotient product rule formula, which we have not used today, of a over b to the c equals a to the c over b to the c. So what we will do is we'll move the 3 to the x, the 3 to the 4, giving us x to the 3 times 1 equals x cubed. 4 to the 3 times 1 equals 4 cubed. X cubed over 4 cubed. 5x squared cannot be simplified anymore, so we'll just move it to the bottom. And this can be simplified, since a to the negative b equals 1 over a to the b. A equals y, b equals negative 7, giving us 7 over y to the 7th as the simplified form. So as we move the simplified forms to the bottom, we can now combine the numerators and denominators. Thankfully, again, no additional subtraction, so we can just multiply the numerators together and multiply the denominators together. So we'll do x cubed, numerator. We'll do x cubed times 5x squared times 7. We'll do 5 times 7 equals 35. X cubed times x squared equals x3 plus 2 equals x to the 5th, giving us 35x squared as the numerator. When we move to the denominator, we have y cubed times y to the 7th, giving us y to the 3 plus 7, y to the 10th. When we combine the numerator and the denominator, we have 35x squared over y to the 10th. And that is the final answer. Alright, well that's going to be all for today's video. Thanks everyone for watching, and next time we will be continuing our review of pre-algebra before we get into college algebra. Thanks.